All right, the second lesson we're going to do in Chapter 8 is Section 8.3, Special Right Triangles. Again, you can remember we skipped over 8.2. That was supposed to be Pythagorean Theorem, but we've done that previously, and you guys have been great at working with and using Pythagorean Theorem throughout the course of the year so far. So 8.3 is special right triangles, and there's two special right triangles we are going to look at. The first one being the 45, 45, 90 triangle. And what that means is that we know a triangle has three angles, and these angle measures are going to be 90 degrees, 45 degrees, and 45 degrees. So 45 plus 45 is 90, 90 plus 90 is 180. So it all still adds up to 180 degrees. And I know throughout the course of me teaching this, some students, they continue to use Pythagorean Theorem, and that's fine. It will get you an answer. However, that will give you, it might take you a little bit longer, we'll just say it that way. So by all means, feel free to use Pythagorean Theorem if you need to for different things, but it does really help you, and it allows you to see, I don't want to say some shortcuts, but just some different things that happen with these types of triangles that consistently happens. So the first thing with this theorem, it says in a 45, 45, 90 triangle, the length of the hypotenuse is the square root of 2 times the length of a leg. So the one thing we do need to mention that in a 45, 45, 90 triangle, both legs are the same length. And in this case, they've called them both n. I sometimes just call them L for leg, but you do have to use a cursive L so that it doesn't look like a 1. So the other thing I'm going to give you throughout this lesson are some different little like formulas, if you will, or different little equations that come from this. And so it says right here what one of them is. It says the hypotenuse is, so I'm going to do H is in math means equals. It says the square root of 2 times the length of the leg. So I usually do the leg or just L times the square root of 2. So the shortened version would be L root 2. Okay, so if you can remember that, you are good to go for this first one. So it says, first example, the wallpaper in the figure can be divided into 4 equal square quadrants. So that each square contains 8 triangles. So 1, 2, 3, 4, 5, 6, 7, 8. That's what they're talking about right there. Whoops. Oh my goodness. There we go. What is the area of one of the squares if the hypotenuse of each 45, 45, 90 triangle measures 7 root 2 millimeters? Okay, so they're asking for the area of one of the squares. So this is going to be multi-step. So they want the area of one of the squares. All right, so here's one of the squares that they want the area of. Okay, so we first have to find the area of one of those little triangles because that's what they're talking about. It says the hypotenuse of the 45, 45, 90 triangles. So that means, let me erase this since that's really dark. One of these little triangles, they're all right triangles and they're all the same. We're going to have to find the area of one of those first and then multiply by 1, 2, 3, 4, 5, 6, 7, 8, and then we'll have the area of that whole square. Okay, so let's start with that. So first things first, because like I said, this is going to be a several step problem, is they told us the hypotenuse. So we know from this little theorem up here that the hypotenuse is equal to the long leg times the square root of 2. So let's go about finding the length of this leg. And I apologize, I did say long leg, and you're going to see why here in a second. So the hypotenuse in this case was 7 root 2. So I'm going to replace H with 7 times the square root of 2. And then my leg times the square root of 2. To get the length of the leg, and maybe I should tell you why we need the length of the leg. Because for the area of a triangle, it's 1/2 base times height. So say that's my base, that's my height. We need to know the length of those legs. Knowing the length of the hypotenuse, that's not helping us too much. All right, so going back to here, to find the length of the leg, now that we know why we have to divide both sides by the square root of 2, and maybe I should show that. So square root of 2 divided by the square root of 2. Well, both square roots of 2 cancel. So that means the length of the leg is just 7 millimeters. Okay? So the great thing, since it's a 45, 45, 90 triangle, we know that h, which is the height, and the base, they are both the same. So now we can find the area of one tiny triangle. So 7 times 7. So 7 times 7 is 49. Might as well write all this out. And then half of 49 is 24.5, we'll say, millimeters squared. All right, so this is area of one triangle. Okay, but if you recall, there are 8 triangles. There are 8 of them. And some of you are saying, Miss Hager, I probably could have done this a different way. And we'll look at that in a second. But there's 8 little triangles. So now I'm going to take 8 times 24.5 to get the area of the square. And that ends up being approximately 196 millimeters squared. All right, and then the other way, I'll just sort of go through it off to the side with one of these other ones. I'll use this one. So if that's 7, that means this is 7, which means that side is 14. That is 7, that is 7, so that means that side's length is 14. And now to find the area of a square, we take length times width, and 14 times 14 is 196 units again. So just to show you, there are several different ways to find that, but the key to this problem is we had to do step 1 to find the length of that leg, so that way we could either use the triangle formula and then multiply, or just take the length of one side, which is 14 times 14. Oh my goodness, I actually used the x in there for multiplication. Let's not do that. There. And we still get 196 millimeters squared. All right, so either way, you get the point. So take a moment, try the your turn. I am going to give you a heads up. This one's not asking for area. It wants the perimeter of the entire square. So when they mean the entire thing, they mean this whole outside. Okay? They want the whole outside piece there. Not just one of those squares. They want the whole entire thing. So take a moment, pause the video, try this next your turn. You notice I almost put squared at the end. All right, so you should have come up with 80 millimeters. If you didn't, go back, double check my work, and see where you made your mistake. All right, so for now we're going to move on to example 2. They're not telling us a story about this triangle. They're just asking us to find different lengths. So in these previous problems, they have given us the hypotenuse. And you can see that's what they're doing here again as well. Will they always give us the hypotenuse? Nope. Sometimes they will give us the leg and we have to find the hypotenuse, but that's actually usually the easier type of problem. So find A, so that's the length of a leg. So we know that the hypotenuse hypotenuse is the leg times the square root of 2. So we know 8 is equal to a root 2. Now you will see I have to divide both sides by the square root of 2. Doesn't work out to be so nice here. So you can write this as a decimal. So if I do that, let me figure out what that is here because I only have the other version I'm going to show you. That means the leg is approximately 5.66, okay? So 5.66 centimeters. However, typically when they do this, they prefer you to leave it in radical form. I really wish we had more time, and I've been struggling which method to require or what solution. So I would be okay with the decimal, even though that is not the most preferred. I would also be okay with 8 divided by the square root of 2, although it is almost never encouraged to leave a radical in the denominator. It's something we don't do. We never leave a radical in the denominator. We do a process of what's called rationalizing. And I'm going to show you here quick what rationalizing is. And you may have done it before, especially if you've had Algebra 2 already. You should be very well accustomed to this. But for those of you that are not, I'm just going to show you quick because it's not hard. But you will do it in Algebra 2. So we rationalize the denominator because we don't typically like to leave a radical in the denominator. All right, so to get rid of it, we are going to multiply this by a 1. But the 1's going to look a little different and say, okay, if I want to get rid of that square root of 2 in the denominator, guess what I'm going to multiply both numerator and denominator by? The square root of 2. So now let's see how this plays out. So multiply straight across because that's how we multiply fractions. So we end up getting 8 root 2 over the square root of 2 times the square root of 2. And you're thinking, well, Miss Egger, square root of 2 times the square root of 2, well, that's the square root of 4. If I can write a 4 in there. And then you're thinking, well, the square root of 4, that's just 2. And then we say, oh, well, now look, I have an 8 and a 2 there outside of my radical, so we can simplify that. 8 divided by 2 is 4. So the best answer would be 4 root 2. Okay, so that's rationalizing in a nutshell. And actually, I say nutshell, but that is exactly it. So 4 root 2 centimeters is the best answer for that problem. All right, so now take a moment, try the your turn, and then come back and check your answer. All right, so you should get 3 root 2 approximately, or 6 divided by the square root of 2. All right, so moving right along, we get to now look at the other type of triangle. And these actually, we're just going to do, this is going to be our last example because we're able to, or we are supposed to shorten some things. We're actually, and I know you guys are going to be upset, we're going to skip example 4, skip the your turn, which also means if you scroll down to this practice work, you don't have to do number 13 either. So you only have 12 questions for the practice work tonight. If we were in school, that is one topic we would get to, but since this is actually our last chapter we're going to be able to cover so that we can shorten some things, we're eliminating example 4. So let's go ahead and take a look at example 3. So example 3 deals with theorem 8.7, and it's talking about a 30, 60, 90 triangle. So that means I have a right triangle because of the 90, And the other two angle measures are 30 and 60. Now remember, this whole theorem only works if it's 30, 60, 90. It doesn't work if it's 29, 61, and 90. It has to be 30, 60, 90. And it says in a 30, 60, 90 triangle, the length of a hypotenuse is twice the length of the shorter leg, and the length of the longer leg is the square root of 3 times the length of the shorter leg. So they went through and they talked about hypotenuse. They talked about a short leg and a long leg. So thinking back to, oh my goodness, I don't know what chapter, one of those with the triangles, the shorter side is across from the shortest angle. So 30 degrees is smaller than 60. So that must mean this side here is my short leg, which we're going to do SL or just S for short leg. And the side length across from 60, that's my long leg, or I typically just do L for long leg. Okay, so we have a short leg, a long leg, and a hypotenuse. And this one is actually going to give us two different formulas. Okay, I'm just going to put an L there for long leg. Because if you look, the first one says the hypotenuse is twice the length of the short leg. So hypotenuse is twice the length of the short leg. Okay, notice how we have 2S, they have 2N because they call the sides N. And the second one, let me get a different color, says the length of the longer leg is the square root of 3 times the length of the shorter leg. So the longer leg we called L is equals, it says the square root of 3 times the shorter leg. So S root 3. So that's where they're getting all of that information in that triangle. I tend to like to use S and L for short leg, long leg, but that's just my personal preference. You feel free to use your N's if you prefer. All right, so example 3 says find QR. So we have to find the length. In this case, QR actually ends up being my, here I go again, my hypotenuse, because that is the one across from my 90-degree angle. So I'm going to label all of these. So that means this is my hypotenuse. Here's my 30-degree angle. So that must mean 4 root 3 over 3 is my short leg. If that's 30, that must mean this is 60. So the one across from it, that's my long leg. So first things first, always label your triangle. Now QR, that's my hypotenuse. So let me scroll down a little bit. So to find my hypotenuse, I need to know the short leg. So that's H equals 2S. Well, if we look, we do happen to know the short leg here, so all we have to do is substitute it in. So 2 times 4 root 3 over 3. Now don't forget how to multiply these. I can put 2 over 1 and then multiply straight across. So 2 times 4 is 8 root 3 over 3, which that is 100% an acceptable answer. If you wanted to write in decimal, that would be 4.62. Okay? Oh, and that's centimeters. All right, so this one we only needed to complete one step to get our solution. Okay, we asked for hypotenuse, they gave us a short leg, we were good. Okay, but you're going to see in this your turn, and actually I'm going to go through this one with you. You can pause the video, try, but you do have to take a couple steps here, 2 steps to be exact. All right, so find BC. So BC is my hypotenuse. B to A is my short side. If you're noticing right now, to get the hypotenuse, we need the short leg. Guess what they did not give us? The short leg. So that's why we have to take several steps here. So first step, let's take a look. We want the hypotenuse. So hypotenuse is going to be 2 times the short side. We don't know the short side, so guess what? We have to move over here. So we'll do step 1, step 2. All right, so what do we know? We do know the long leg, so I'm going to use the formula for the long leg. So the long leg is equal to the short leg times the square root of 3. I don't know the short leg, but don't forget, we do know the long leg. So I can substitute 4 root 3 in for that. And then notice, all we have to do is solve for s. And some of you were thinking, Miss Egger, I could have just looked at the triangle above, and that is 100% correct. So we end up getting the s is 4. And what I mean by the triangle above, if the long leg is n root 3 and they already had root 3 in the problem, I'm just showing you using this equation because sometimes it doesn't always work out to be the square root of 3. So now we have that s is 4, so we can come back here and substitute it in. So we get h equals 2 times 4. So my hypotenuse is 8 inches. All right, so you guys do have your practice work. If you do need more practice, since we're skipping those two, I didn't give you a ton of stuff to do here, but if you need more practice, the larger practice packet that we typically do, that is in this folder. So do this practice work. If you need more review, you can take